Alright, so bacteria in the classroom. Today we're going to be looking at solving some exponential equations. So it says at 11 a.m. Sally leaves a serving of yogurt on a table. The number of bacteria in the yogurt at the time is 1. So there's 1 bacteria in the yogurt. The number of bacteria in Sally's yogurt increases by a factor of 4 every minute. So it's multiplying by 4. So it's times 4 times 4 times 4. And then 3 minutes later at 11:03, Lupe leaves a serving of yogurt on a heater. The number of bacteria in Lupe's yogurt at that time is 1, but due to the increased temperature, it's increasing by a factor of 8 every minute. So if we take a look at this, that means Sally's going by a factor of 4, so 16 times 4 is 64. And this is where Lupe starts at 1, 11:04, 256 for Sally, and then 1 times 8 is 8, 11:05. We have 1024 for Sally. 8 times 8 is 64. 11:06. We have 4096. And then 512. 11:07. We have 16,384 and 4,096. And then 11:08, we have 65,536 and 32,768. 11:09. So 11:09, so if we would add in 11:09 here, 11:09, we have 262,144, and we have 262,144. So at 11:09, so Sally and Lupe's yogurt will have the same number of bacteria at 11:09. So Sally and Lupe's yogurt will have the same number of bacteria at 11:09. So at 11:09 they will be the same. So today we're going to be doing a guided exploration of solving exponential equations. So if we look at this first one here, it says complete the following examples. Well, if 2 to the x equals 2 to the 5th, well, that just makes sense that x should equal 5 because they should be the same. So 2 to the 5th should equal 2 to the 5th, so x should be 5. And number 2, if 3 to the x equals 3 to the 4th, well, then x should just equal 4. So it's 3 to the 4th equals 3 to the 4th. And if 5 to the x equals 5 to the 7th, then x should equal 7. And if 10 to the x equals 10 to the negative 9th, x should equal negative 9. 1/4 to the 7th, 1/4 to the x should equal 7. And if 9 to the negative 2nd equals 9 to the x should simply equal negative 2. So if you notice, these are all just equal to each other. So they're all equal to each other. Well, and then we get down to this. Well, what did we just find out? If 2 expressions with the same base are equal, then their exponents must also be equal. So our symbolic terms, if x to the a equals x to the b, then what we know is that a is equal to b. So a has to equal b. So if we look at a couple examples here, so if we have 6 to the x equals 6 to the 5th, well, the bases are the same, so that tells us that x is equal to 5. So we know that x is equal to 5. And if we look at number 10, well, we have 1/7, 1/7, so our bases, 1/7, well, we know that 8 is equal to x. Number 11, we have a base of 3 and a base of 3. Bases are the same, so x equals negative 10. Number 12, we have a base of 2 11ths, a base of 2 11ths. So negative 5 equals x, or we can say x equals negative 5. They both mean the same thing. Then we get to number 13. Well, this says 2 to the x equals 4. Well, this is the base of 2, and this is the base of 4. Well, they're not the same bases, but we can make them the same bases. Alright? When they're not the same, well, we know that 4 is really 2 times 2. Well, 2 times 2 is the same thing as saying 2 to the power of 2. So we can say that it's 2x equals 2 to the second power. So now they have the same base, so it's 2 and it's 2, so x is equal to 2. If we look at 14, well, 3 to the x equals 27. Well, 27 is 3 times 9, and which is 3 times 3 times 3. So this can be said as being 3 to the third power. So we broke it down. So if you didn't know that 27 was 3 to the third power, well, that's how we broke it down. 3 times 9, and 9 is 3 times 3, so it's 3 times 3 times 3. So we get 3x equals 3 to the third power. Well, now we have the same base, so x is equal to 3. Now we can fill in this chart. I'll quickly just going to fill in the chart. You can pause it and go back. So all these are 1. 1 to any power is just 1. So 2 to the negative, this is 1/4. This is 1/2. This is 1, 2, 4, 8. This is 1/9. This is 1/3. 1, 3, 9, 27. 1/16. 1/4. 1, 4, 16, 64. 1 over 25. 1 over 5. 1, 5, 25, 125. When we get to 6. So these are some base 10s, powers from 1 to 10 that you should know. 6 times 6, so it's 1 over 36. 1 over 6, 1, 6, 36, 216. 1 over 49, 1 over 7, 1, 7, 49, 343. 1 over 64, 1 over 8, 1, 8, 64, 512. 1 over 81, 1 over 9, 1, 9, 81, 729. 1 over 100, 1 over 10, 1, 10, 100, 1,000. And I'll give you some time to copy it, but just pause it and I'll move on. Now, what we're going to look at 15, 16, we're going to look at solving these. So if we look at number 15, well, we look at 1/4. Well, now if we go back to our chart, well, 1/4 is right here. So here's 1/4. So 1/4 is the same thing as saying 4 to the negative 1 power. So this is the same thing as saying 4 to the negative 1, which makes sense because this is 4 to the first. Well, we do the opposite, so we make it negative. Negative is going to put in the denominator. So now we have the same base of 4. So x is equal to negative 1. So once again, we have 1/4. So what we can say here is that 1/4, but this is a base of 2. So we don't want to look at the 4 column. We want to look at the 2 column. Well, here's my 2 column. Well, 1/4 is right here. So 1/4 is the same thing as 2 to the negative second. Another way we can look at it is saying that this is the same thing as 1 over 2 to the second. Well, 2 to the second in the denominator is going to be 2 to the negative second. Same bases, x is equal to negative 2. If we look at 17 and 18, well, 5x, if you find, we're looking for a base of 5. If you look at the 5s, and you're going to find 125, so that's going to be 5 to the third power. So x is going to equal 3. If we look at the next one, base is 8. So we're going to look at the 8 column, and we're going to find that 1 over 64 is going to be the same thing as 8 to the negative second. Bases are 8, they're the same, so x is going to equal negative 2. (19) 25 to the third and 5 to the x. Well, now watch what happens. These bases are not the same. So we have 25 and we have 5. Well, when you go and we find 25, well, 25 is the same thing as 5 to the second. So what I'm going to do here is I'm going to change my 25 to 5 to the second, but I still have this 3. So I still have this 3, and it still equals 5 to the x. So all I did was replace 25 with 5 to the second. Now, my laws of exponents tell me that I multiply these two numbers. So this is going to be 5 to the 6th power, and it's going to equal 5 to the x. Now my bases are the same, so we have 6 is equal to x. And when we look at 20, well, now we have 100. Well, 100's not on that chart, but we know that 100 is the same thing as saying 10 to the second power. Well, it's 10 to the second power raised to the x.
Miss Bay, could you come by the main office, please?
And 1 over 1,000 is the same thing as 10 to the negative third. So now what we do is we can say that, well, this is 10, we multiply these, 2 to the x equals 10 to the negative third. Same base, so we have 2x equals negative 3. And now we have to solve this, so the way we solve it is we divide both sides by 2. X equals negative 3 divided by 2. And if we look at, we'll look at a couple more of these. If we look at 21, we have 10x. 1 over 1,000 is the same thing as 10 to the negative third, but it's raised to the power of 5. So we have 10x equals negative 3 times 5, which is 10 to the negative 15th. So we have our bases of 10, so x is equal to negative 15. When we look at 22, they don't have the same bases, so we can change 9. Well, 9 is 3 to the second power times 4 equals 3 to the x. Well, we multiply these two, so this becomes 3 to the 8th equals 3 to the x. So same bases now, 8 equals x. So our goal here is to get the bases to be the same. Then we get to 23 and 24. So we'll just quickly do 23 and 24. So 23 says 7, and then we have 2x minus 4 equals 7, and 9 minus 2x. Well, these bases are the same. So what we can say is that 2x minus 4 equals 9 minus 2x. Same bases. Now we solve it, so we want to do plus 2x plus 2x. So we have 4x minus 4 equals 9 plus 4 plus 4. 4x equals 13, and divide by 4. X equals 13 divided by 4. And then with 24, we have 4 to the negative 6x equals 4 to the 12x minus 7. Bases are the same, so once we have same bases, we can set these equal to each other. negative 6x equals 12x minus 7. To solve this, we want to get the x's by themselves, so we do minus 12x minus 12x. So I have negative 18x equals negative 7. Divide by negative 18. X equals 7 divided by 18. And then you can work on 25 through 32. And that is looking at solving the exponential equations. We need to get the bases to be the same.